In this video, we're going to explore the test and planning facility available in Reliasoft Wible++ for accelerated live testing. So what we can do, we can scroll down this menu with all the different types of analysis that are included in Wible++ with his add-on, and we can find this ALTA test plan. Alternatively, we can go under test and planning, right click, and we select ALTA test plan. So once we selected ALTA test plan, we're left with this window where we have to analyze every single element and decide what information we want to select or information we need to add. So for example, number of simultaneous stresses, we have a choice of 1 or 2. Let's keep things simple for this video, so we use 1. And then we have different types of test plan, which are either a 2-level or a 3-level. So we're going to go for a 3-level, and we're going to choose the last one, a 3-level with a redistribution of units 4 to 1. And this is quite handy because, say for example, 4 to that's 7. So if we have, say, 21 units, we can redistribute 12 on the lowest level, 6 on the intermediate level, and 3 on the highest level. So we choose this redistribution of units, we leave this low stress adjustment factor to 1, we don't make any correction, and then this is what we are looking for. We're looking for a B10 life, and we have available 1 month, which is equivalent to 720 hours. And we want to get both the redistribution and the quantity of unit, even though we know there's going to be a ratio for 2 and 1. And the number of units available, we say we're going to put 21 on test, and the live data distribution of our unit is governed by a Wible distribution, and the information we gather is the shape parameter is 3.6. And then as we choose one stress only, we configure just this part, otherwise we'd have had a second stress to configure. So we assume we're dealing with the thermal stress, so we select the Arrhenius relationship, and the use stress level are 300 Kelvin, and which is 27 Celsius, and the highest stress level, the maximum stress level, is 383, which is 110 Celsius. And the last two questions are the most difficult one, because the software basically has asked us to try and derive a life stress relationship. So we want to estimate the probability of failure at 720 hours, which is our time of test, length of test, and is asking us to estimate the probability of failure at use stress level, so at 300 Kelvin after 720 hours. Say we put in, the figures are in percentage, so we put in, say, 1%, and the probability of failure still at 720 hours, but at a stress of 383, we assume, say, 30%. So once we've input all this information, we're ready to calculate. So we calculate, we go on this icon, and we click calculate. And all this information up to here represents our input, and if we're not happy, obviously we can go back and change it. And here instead is our output. So basically the software recommends that the low stress level being 321, 322 Kelvin, the mid stress level is about 350, and the highest stress level is the one we said was 383 for an extrapolation at 300 Kelvin. And the redistribution here is in percentages, but here this is what we define in our setup. And then this is the calculation of the probability of failure. So we have about 3% probability of failure at low stress level. We have about 9% middle stress level 350, and we got 28% at 383, which is our maximum stress level at 720 hours. Okay? And then also it tells us some information. The time at which we have a 10% probability of failure is after 1,383 hours, and this is the variation of our data, and that's something that we need to look at when we get the results, because when this one is very wide, it means that our results are very uncertain. And we can also use this test plan evaluation here on the right hand side. Say for example, we can use them. We're obviously reanalyzing these data, but say we want a confidence band on our results of 80%, and so we want the sample size. Yes, we'll say the sample size. We got bounds ratio. Okay, so we have an 80%. We want an 80% confidence band. We have 21 units. Let's see how much uncertainty we got. We got a bound ratio of 7.5 roughly, which means that our projection, our beta and life between the highest level and the lowest level, I got a bound ratio of 7.5. If we're not happy with that, if we want to reduce the variability of our data and therefore reduce the uncertainty, we can go on a sample size. We know that if we increase the sample size, we'll reduce the uncertainty. And say, for example, we want a bound ratio or about 5, and let's see what sample size. So we got 21 units. It tells us basically you got to go up to 33 roughly. And obviously we can decide whether that is feasible or not, or try some alternatives. And so this facility is quite useful to experiment with some of the design before starting off, and having some idea in terms of levels and also the distribution of the unit and the sample size needed. And that's it.